So in my previous previous lectures I discussed impulse. Uh, so I think if you are going to recall it, I told you that what impulse is, that is equal to force into this time duration, and what it is equal to change in momentum. So like this impulse is denoted by J. This is the force which is applied for a time delta t. So this is denoted by J. Okay. What was the change in momentum? Suppose due to this force which is applied for this time delta t is that's the final momentum minus initial momentum. This is the final momentum minus initial momentum. So this was the thing which I discussed. Suppose what is momentum? I told you that is linear momentum, that is equal to m into Vf. If it is a final momentum, then it is m into Vf. If it's an initial momentum, then it will be m v I, where Vf is the final velocity and Vi is the initial velocity. So if I'm going to write it simply, it will be like S impulse is a vector quantity. This force is also a vector quantity. This is for delta t, or leave it. So in another word, you can say F into delta t is equal to Pf minus Pi. If someone or here, so this is what we discussed earlier. So like let us see some scenario. Okay, so suppose this is our wall, and suppose this is our ball. Okay, so like it is moving towards this side with the initial velocity u. It reaches there, like it reaches there. Make it like this. It reaches there, here. It strikes here, and after that it returns like this. Same, same way. The thing is that here what we are considering, whatever was the strike of this velocity here in this direction, in return also it is having the same velocity. Okay. Means I think you will come across one thing, that is elastic collision, and all these things we will discuss in our collision chapters. But for the time being, or consider this thing only, that after collision this ball come back with the same velocity, means it strikes the wall. This is your wall. It strikes the wall with this u velocity, and after that it comes back with the same u velocity. Suppose the mass of this ball is m. So what is the momentum here? Like I will be considering this part. Suppose the time duration each t. The time duration, this is the time of contact, you can say time of contact with wall. So you can say like this is the delta t, what it is. This is the time of contact, like ball come here, hit it here, then stay there for delta t time, and after that uh, it returns back in the same direction. Okay, so like when it strikes here, initially, so like the what will the momentum? That's the initial momentum. What's the momentum? That is m into vi. So the thing is that here the u is in this direction, like you can see here it is in this direction. So like we are considering this as positive, this is negative, this is positive, this is negative. So like our u is in, you can see here, like so you can see here like it's in this direction, positive direction. So what will be our p momentum initial? That will be m into u. What is our momentum? What is our momentum here? P final, that will be minus mu. Why minus mu? Because you can see here the direction is in this direction. So what would be the change in momentum? Pf minus pi, like this one, pf minus pi. So pf, what is pf? Minus mu and minus sign again mu. Pi is minus mu, that is equal to minus 2 mu. And we have, I told you that this ball is here for delta t time. So as I told you here, this is f into delta t. I am going to write it here, f into delta t. And what f will be? Minus 2 mu over uh, delta t. So what is this force? So you can say like here what we got here, that is, you can say this is the force which is exerted by wall on the ball. Got it or not? The thing is, this is the force what is, this is the force exerted by wall, this wall on ball. Okay, so like we discussed Newton third law. What it was like, if you are going to like in every action there is equal and opposite reaction. So like I told you very lot of examples there, if a mass is kept on a table, so like normal force will act on it, है ना? So like when we are going to draw the free body diagram of that, so the normal force will act upwards in this body, and the same normal force will act downward on this earth. So like you can see here, this ball, the force exerted by wall on the ball is this much. Minus sign here, minus sign indicates the direction that it is in this direction, because we are considering this as the minus sign. You can see here we are considering this as the minus sign, this direction. So this is the like in other words you can say that this is the wall, and the force exerted by ball, this is the like this is 2mu over delta t. So this is the like there will be two forces, like this is the force. Why is it so? Because the thing is that both will be same, like let me write it first. Force exerted by ball on wall. So this impulse, so the same thing is here, like I told you that a normal reaction will be acting here, and this much n will be acting here. So same thing is happening here, like this ball will experience the force that is in this direction. This ball, you can say ball will be having uh, um, 2mu over delta t, but the thing is that in this direction, so that's why I showed here minus sign, because we are using this sign convention, so it will be like this only. Okay, and this wall is will experience a force of, you can say, 2mu over delta t. uh, I'm repeating the thing again, like this ball strikes the wall with a velocity u and bounce back again with the same velocity u. So the initial momentum before collision was mu, and the final momentum, as we are considering the minus sign here, so the velocity direction is this direction, so we wrote it minus mu. Okay, so what would be the change in momentum? That is pf minus pi. So minus mu, which is pf minus mu, minus minus mu, that is 2 minus mu. And what we have, just the impulse part, that is F into delta t. So that F came out will be 2 mu over delta t. So this is what the force exerted by wall on the ball. What is the force on the ball, you can say? Force on the ball will be this much, but in this direction. You can say I showed you here. Like I see here, like force on the ball will be in this direction. 2 mu over delta t, and there will be, as per Newton's third law, there will be equal and opposite force. So this wall will also experience the same force, like 2 mu direction. Ball will experience in this direction, wall will experience, this is ball. So wall will experience in this direction, and ball will experience in this direction. Why we got it here? Because we got the minus sign, and minus sign is an indication of what we have here. So by the help of this impulse definition, you can say, we are able to find out the force exerted by ball on the wall and wall on the ball. So both things we got it here. Let's change the scenario a little bit. Mm. Like suppose this is our wall, and suppose ball is here. This is your ball, and it strikes like this. At this point, it stays here for delta t time. Ball stays here for delta t time. Okay, like here, and it strikes with u velocity. Okay, and after that, uh, it bounce back. Again, also we are considering the same velocity. Like here, it comes back with the same velocity u. Like angle of strike, what we are considering, like this one as theta, and this one also as theta. So you can see here, like ball strikes this wall. Suppose this mass of this ball is m. It strikes this wall, stays here for delta t time, and after that uh, it returns back in the same angle. You can say theta, making a theta with the normal. You can say normal line or any line. You can say. So the thing is that let's find out the components. I told you that component section is there. So like this one, what would be the horizontal component, what would be the vertical component? So how to, this one is theta, this one will also be theta. So if this is u, green color line, this u green color line is u. So what would be the component in this direction? That would be u cos theta. And what would be in this direction? That would be u sin theta. Here also let's take out the components. So like this angle is theta. So this will be u cos theta. The thing is that I told you the signature part, like we are considering like this. So this we are considering this direction. If this is this direction, we are considering positive. This direction we are considering negative. This direction we are considering positive. This direction we are considering negative. So like you can see here, like let's put the sign here. So this will be negative. This will be negative. And what about this one? U sine theta. This will also be negative. As I told you, this one. And here in above part, this one will be negative. So like there are two parts. Like let's see the initial momentum that is in horizontal part. Uh, First we are considering the horizontal component, or you can say x component, y axis. Okay, so like we will be considering x component. Okay, horizontal component or x component. So what would be the initial momentum in x direction? What would be the initial momentum in x direction? So it will be, suppose the mass is mu cos theta. This u we are considering this part. So it will be mu cos theta. And here we'll be writing vertical component y-axis. Y-axis or y component you can say. What would be the final momentum? P final in x direction, horizontal direction. So this will be minus this part, minus u cos theta. So m into minus u cos theta. So it will be equal to minus mu cos theta. What would be initial component in y direction? So we are considering this part. What it is? M into minus u sine theta is equal to minus mu sine theta. What would be final component of final momentum in y-axis? Yeah, this one is so about this one. Okay, so here also you can see a minus sign. So this will be m into minus u sine theta is equal to minus mu sine theta. So what would be the change in momentum along x-axis? So that is fx delta t is equal to force along x-axis Fx delta t is equal to Pfx minus Pix. Along x-axis we are talking about. So along x-axis, so it will be what is minus mu cos theta minus mu cos theta minus mu cos theta minus mu cos theta. It will be equal to minus 2 mu cos theta. So what would be F along x-axis is equal to minus 2 mu cos theta over delta t. So like here we are considering minus sign. So our force is in this direction, means along x-axis the force on this ball if this is our ball, it will be along x-axis, this will be this much Fx. Let's find out the Fy also. Fy into delta t is equal to Pfy minus Piy. What is Pfy? Minus mu sin theta minus mu sin theta minus, and again minus mu sin theta, again minus mu sin theta. So this will come out 0. You can see it, this minus sign, it will become plus sign, and minus plus, it will become 0. So our Fy is equal to 0. Our Fy is equal to 0. So we have only force in x direction. So like this is what is this force? This is the force, you can say force exerted by, same thing like Newton third law of motion is there. So like our wall will experience, like I told you that if some block is here on earth, so in normal, when we are going to draw the free body diagram, so normal reaction will come upward, and this earth we are going to show it like this due to Newton third law, that is action or reaction. So this ball will experience like Fx is equal to 2 mu cos theta over delta t force, and this wall will experience two same force, because action and reaction, 2 mu cos theta over delta t. Like here I am not showing the minus sign. Why is it so? Because here I am showing the direction, that's why I am not showing the minus sign. That is for you can see here, like I am showing it that is force in this direction, that's why I showed only here the magnitude, like magnitude, remember magnitude. Okay, that's a vector part, because this force is what, vector quantity. Okay, so like this ball will experience the force in this direction, and this ball will experience the same thing, 2 mu cos theta over delta t in this direction. Okay, now let's consider another scenario. So like in my previous 5 to 10 minutes back only, I discussed one thing, like this is your ball, and if it hits like this and comes back, like if it hits this with velocity u and comes back with velocity uh, u, so and stays here for delta t time, so what would be the force I told you, like for ball will experience how much, for that would be in this direction, it will be, I told you that the force it will going to experience, that is 2 mu over 2 mu over delta t. And what about the wall? That will experience the force of in this direction, 2 mu over delta t. So suppose the thing is, let us consider a case like this ball is moving in this direction, it strike, and this wall, like it is moving here with velocity u, and this wall is coming here with velocity v. This this wall is coming here with velocity v, and consider the same scenario, like it strikes here, stays here for delta t time, and rebounds back. So like here what would be the force? So that we can see here, like we have here earlier, we have here 2m u over delta t. So instead of u, you are going to write it u plus v, or leave it, because that depends upon the situation. But the thing is that we are considering the ideal situation. So so like this is how we have this force here, and So that's all for today. Thank you.